In this video, we're going to go over enthalpy, entropy, and Gibbs free energy calculations. So let's start here. I have carbon in the form of graphite plus oxygen is going to essentially burn to make carbon dioxide. What we need to do is we need to calculate the change in enthalpy. Well, the change in enthalpy is always going to be the enthalpy of the products minus the enthalpy of the reactants. So I'm going to take my product, which is going to be carbon dioxide, and I looked it up in the table, negative 393.5 kilojoules per mole. And I'm going to take that and I'm going to subtract that from the products. Products happen to be 0 and 0, since those are essentially both in their monoatomic state there. So negative 393.5 minus 0, of course, is going to work out to be negative 393.5 kilojoules per mole. So let's calculate the change in enthalpy in this unbalanced reaction. And to balance that, I need to put a 2 in front of the NO and a 2 in front of the NO2. Change in enthalpy is going to be the products minus the reactants. So my products, I'm going to look that up there, 33.85. That's going to be 2 times that number because I have 2 for the coefficient, minus the reactants. And I'm going to look up both NO and O2. So NO is going to be 90.4, O2 is going to be 0. When I solve that all out, that is going to give me negative 113.1 kilojoules per mole. Same thing here. I need to balance that. I need to put a 2 in front of the water and a 2 in front of the oxygen. Now it's balanced, and I can calculate that. So I'm first going to start with the product, negative 393.5 for carbon dioxide, and 2 times water, negative 241.8. And I'm going to subtract from that the reactants, which is going to be methane and oxygen. So that's 2 times, of course, 0. When that all solves out, that's going to be my products, that's going to be my reactants. They add together because they're subtracting a negative number. Works out to be negative 802.24 kilojoules per mole. All right, now I'm going to calculate the change in entropy. Entropy is going to be this last column here. That's going to be S. So that's going to be, of course, products minus reactants. So our product, carbon dioxide, is going to be 213.6, and my reactants are going to be 2.4 and 205.0. So doing the math right there, subtracting from that, I'm going to work out my change in entropy is going to be 6.2 joules per Kelvin times moles. All right, another one where I'm calculating change in entropy, so that's going to be products minus reactants, and I have to balance that. 2 times ammonia, so that's going to be 192.5, minus my reactants, which is going to be nitrogen and hydrogen. And don't forget, I need to multiply that by 3 because that's going to be my coefficient right there. Solving that one out, and so on and so forth, you can see that's going to work out to a negative 199.5 joules per Kelvin mole. All right, another change in entropy. Of course, products minus the reactants, 2 for my coefficient, going to be multiplied by hydrochloric acid or hydrogen chloride, minus my reactants, which is going to be hydrogen and chlorine. That's going to work out to be 10 joules per Kelvin moles. All right, calculating the change in the Gibbs free energy here. We're going to see if it's spontaneous. So I'm going to take my products, which is going to be 2 times carbon monoxide, plus 1 times oxygen, which happens to be 0, and I'm going to subtract from that 2 times carbon dioxide, and when I solve that all out, and of course take products minus reactants, and it's subtracting a negative number, so it's going to add together, then at 514.2 kilojoules per mole, that is going to be non-spontaneous, that is going to favor the reactants. That reaction is not going to take place. All right, let's do another one right here. So of course I need to balance the equation out, and I'm going to take my products minus my reactants. So negative 394.4 times 2 times water. Water is going to be negative 228.6. And of course I'm now going to subtract from that my reactants, the things that I started with there. Solving that out, there's what I'm going to get for my reactants. Here's what I'm going to get for my products. It's going to be subtracting a negative number. That's going to work out to be negative 851.6 plus 50.79. And at the very end, I'm left with negative 800.81 kilojoules per mole. That, of course, is going to be spontaneous. That is going to favor the products. All right, so now I'm actually going to calculate the delta G based on the other things. So I'm going to say that I have a change in enthalpy of negative 356 kilojoules, and a change in entropy of negative 36 joules per Kelvin. Of course, what I need to do is I need to make sure that those are equivalent things. Room temperature is going to be 25 degrees Celsius. Need to convert that to Kelvin, add 273. So that's going to be 298 Kelvin. Now you'll notice right here it's joules, and there it's in kilojoules. So what I'm going to do is I'm going to be converting that into kilojoules, so with the decimal point 3 to the left. So negative 0.036 kilojoules per Kelvin. So that is going to be delta H, which I have right here, minus the temperature times the change in the entropy. So here's my temperature, 298. Here's going to be my change in entropy. So solving that all out, negative 356 minus a negative number, that's going to work out to be negative 345.272 kilojoules. That is going to be a spontaneous reaction. All right, we'll do another one right here. So there's the original equation. The change in enthalpy that I have for this one is going to be negative 75, the temperature 298, and the change in entropy, of course, I need to change that into kilojoules. So I'm going to move the decimal point 3 to the left, negative 0.0807. So I have negative 75 minus a negative number. That's going to work out to be negative 50.95 kilojoules. That is going to be spontaneous. That is a reaction that will happen. All right, another one here. I need to calculate the free energy change. So here I need to change that into kilojoules, just so we're all on the same page here. Here's my equation. The delta H is going to be negative 235.8 minus that. When that all solves out, what I'm going to be left with for a final amount, negative 275.79 kilojoules. This is going to be another spontaneous reaction. Hydrogenation of ethene gas under standard conditions shows a decrease in disorder. Let's determine whether or not this reaction is going to be spontaneous or non-spontaneous. So my change in enthalpy, negative 136.9, temperature at 298 Kelvin, and of course I need to make sure that I'm looking at kilojoules, and this one already is in kilojoules, so I don't need to do any conversion. Delta G, delta H minus temperature times the change in entropy, putting my numbers in there, solving all of that out. What I'm going to be left with at the very end is going to be negative 100.93 kilojoules. That is going to be another reaction that is going to be spontaneous and will take place.